Hi students, welcome back to my space YouTube channel. Now we are going to solve exercise 8.1 question number 9 onwards. First 8 questions already we have done in the previous videos. Now let us solve question number 9. In a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to PQ. These both are equal. It is given that TP and PQ are equal. Then show that there are 5 questions are there. Then in the first question, show that triangle APD congruent to triangle CQB. First we have to prove this triangle and this triangle are congruent. These two triangles. AD is equal to BC. AD and BC are equal because opposite sides of parallelogram. It is given that it is a parallelogram. BQ is equal to PD. BQ and PD are equal, that is given. Then angle QBC, this angle, and angle ADP, this angle. These two angles are also equal. Why? Because these two are parallel lines and this is transversal. We know that these two angles are alternative angles. Alternative angles are equal. So we have got these three things. So we can say this triangle APD congruent to triangle CQB. First question is proved. Then the second part, prove that AP is equal to CQ. AP, this. Prove that AP and CQ are equal. Already here we have proved that this triangle, in triangle APD congruent to triangle CQB, we proved here. From this congruent of triangles, this AP and CQ are corresponding part of the congruent triangles. So this we have proved this easily. AP is equal to CQ. Then the third part, prove that triangle AQB, this triangle, and CPD, this triangle, these two triangles. Prove that this triangle and this are congruent. AB is equal to CD. AB and CD are equal, opposite side of parallelogram. Then BQ is equal to PD, that is BQ and PD are equal, that is given. Like that, angle ABQ, this angle and this angle are alternative angle. Therefore we can say this triangle AQB congruent to triangle CPD. This also we have proved. Then the fourth part, prove that AQ is equal to CP. Here already we have proved these two triangles are congruent. AQB congruent to triangle CPD, proved above. Just we have proved here these two triangles are congruent. Then AQ and CP are the corresponding part of the congruent triangles. So this also we can prove this very easily. AQ is equal to CP, corresponding part of the congruent triangle. Fourth also we have completed. Then the last part, fifth one, prove that, the fifth one what is, prove that this inside this red one, this is APCQ is a parallelogram. Prove that it is a parallelogram. APCQ is a parallelogram. We have to prove this APCQ is a parallelogram. In parallelogram APCQ, AP is equal to CQ. AP is equal to CQ. We have proved already here. AP is equal to CQ. And AQ is equal to CP. AP is equal to CQ. We have proved here. In this quadrilateral, the both pair of opposite sides are equal. If the both pair of opposite sides are equal, this and this are equal, and this and this are equal, then we can say this quadrilateral is a parallelogram. Both pairs of opposite sides are equal, therefore APCQ is a parallelogram. Now let us go to the question number 10. In this question number 10, ABCD is a parallelogram. ABCD is a parallelogram and AP and CQ are perpendiculars. This AP is a perpendicular from the vertices A, which means this is 90 degree, and CQ is another perpendicular from the vertex C. And diagonal BD is a diagonal. Then show that, first part, triangle APB congruent to triangle CQD. APB, this triangle and this triangle. We have to prove this triangle and this triangle are congruent. AB is equal to CD, AB, and in this triangle AB and this triangle CD are equal. We know that opposite sides of parallelogram. Then angle ABP, this angle. This angle and CDQ, this angle are also equal. We know that these two are parallel line and this is transversal. These two angles are alternative angles. Then in this triangle, this angle, and in this triangle, this angle are also equal because both are given, that is 90 degree. It is perpendicular line from the opposite vertices. Therefore, we can say these two triangles are congruent. Triangle APB congruent to triangle CQD by AAS, rule of congruence of triangle. First part is completed. Then second, we have to prove AP is equal to CQ. These perpendiculars are also equal. We have to prove AP is equal to CQ. Already we have proved here these two triangles are congruent. We have proved here triangle APB congruent to triangle CQB. Then we can prove this easily because AP and CQ are corresponding part of the congruent triangle. It gives AP is equal to CQ, corresponding part of the congruent triangle. Question number 10 is completed. And let us go to the next question. Now let us solve question number 12. ABCD is a trapezium in which AB parallel to CD and AD is equal to BC. This and this are equal and these two sides are parallel. ABCD is a trapezium. These three things are given. AD is equal to AD and BC are equal, and AB parallel to CD and AD parallel to CE. We have constructed this part also. AD parallel to CE. It gives ADCE is a parallelogram. Therefore, we can say ADCE is a parallelogram because these two sides are parallel and this are also parallel. Two pair of opposite sides are parallel and equal. Therefore, we can say ADCE is a parallelogram. It gives DA is equal to CE. DA and CE are equal, and DC is equal to DC and AE are also equal because it is a parallelogram. BC is equal to CE. BC and CE are also equal. AD is equal to BC. That is why it is BC and CE are equal. Angle CEB. CEB. This angle and angle CBE. This angle are also equal. These two angles are also equal because these two sides are equal. These two angles are opposite of the equal sides. Opposite angles of equal sides are these two angles. Therefore, we can say these two angles are also equal. Angle CEB is equal to angle CBE. These two angles are equal. This we can write angle CEB. We can write as 180 minus angle DAB. Why? Because we know that this is a parallelogram. This angle, sum of the adjacent angle is 180 degree. So this angle we can write as 180 minus angle A. This part. Like that. Angle CBE. This angle we can write as, we know that this and this are linear pair. This plus this is 180. Therefore, this we can write as 180 minus this angle. 180 minus angle ABC. This angle. Now the equals are cancelled. So we can write angle A. Angle DAB. DAB is A is equal to angle ABC. ABC. This angle. So this angle and this is A, this is B. These two angles are equal. Angle A is equal to angle B. First part we have proved. Then let us go to the part second. We know adjacent angle of a parallelogram are supplementary. Angle A plus angle D is 180 degree, like that. Sum of the adjacent angle is always supplementary. Angle A plus angle D 180 degree, as well as angle B plus angle C is equal to 180 degree. It gives angle A plus angle D is equal to angle B plus angle C. These both are equal because sum of these two pair of angle is 180 degree. Angle, it gives angle B plus angle D is equal to angle B plus angle C, because already we have proved angle A is equal to angle B. Instead of angle A, we wrote angle B. Now this equals are cancelled. we get angle D is equal to angle C. That also we have proved. Angle D and angle C are also equal. Then the third part, in triangle ABC, this, let us join this some part here. This diagonal AC and diagonal BD. In triangle ABC, this triangle, ABC, this triangle, and BAD, these two triangles we are taking, BAD and ABC, these two triangles, this and this. AB is equal to BA. In this both triangle, AB is common. AB is equal to BA. AB is equal to AB. Then angle B is equal to angle A. Angle B and angle A are equal. That already we have proved. And AD is equal to BC. AD and BC are equal. That is given. Therefore, we can say triangle ABC. This triangle and this triangle are congruent by SIS rule of congruence of triangle. This we proved these two triangles are congruent. Then for fourth part, already we have proved here triangle ABC congruent to triangle BAD proved above. Then we know that AC is equal to BD. If these two triangles are congruent, this AC and BD are corresponding part of the congruent triangle. They are equal. AC is equal to BD, CPCT. That is AC. What is here AC? AC is the diagonal. Diagonal AC is equal to diagonal BD. Then we can say here this diagonal, both diagonals are also equal. Diagonal AC is equal to diagonal BD. Exercise 8.1 is completed. Thank you, students. Please subscribe this channel. Remaining all exercise, their answers and explanation will be available in MathSpace YouTube channel. Please subscribe.